What if you tried to microwave the moon? This question comes from someone with access to way too many kitchen appliances and apparently not enough supervision. This question comes from someone with access to way too many kitchen appliances and apparently not enough supervision. Your microwave, on the other hand, is a box with a spinning plate inside that uses electromagnetic radiation to warm leftover pizza. Naturally, the first challenge is scale. Microwaves are small, the moon is not. So to microwave the moon, you'd either need a really big microwave, or you'd need to shrink the moon down to fit inside your average kitchen model. Let's start with the first scenario, building a microwave big enough to fit the moon. We're talking about a device large enough to surround a celestial body. This wouldn't just be a microwave anymore. This would be a planetary-scale death ray, capable of emitting gigawatts of microwave energy directly into the surface of the moon. Also, it would have to be in space, since there's no extension cord long enough to plug it in from Earth. Let's assume you solve that problem with solar panels the size of continents, and space infrastructure rivaling the entire global economy. You position your super microwave in lunar orbit, lock the moon inside, and hit the button labeled Reheat Moon. Here's what would happen. First, you'd need to understand what a microwave actually does. Microwaves work by emitting electromagnetic waves at a frequency of around 2.45 gigahertz. This frequency causes water molecules to vibrate, producing heat. So microwaves don't heat food directly. They agitate water, and the water heats the food. Here's the problem. The moon is extremely dry. Like Sahara Desert meets Death Valley meets vacuum of space dry. The lunar surface contains only trace amounts of water, mostly bound up in hydrated minerals. In other words, your giant space microwave would have very little to work with. You'd start heating tiny pockets of water in lunar rock, and they'd begin to boil and evaporate. But because the moon has almost no atmosphere, that water would immediately sublimate into vapor and escape into space. Congratulations, you just dehydrated the moon even further. However, lunar soil, or regolith, does contain metal oxides and glassy particles, some of which can absorb microwave energy directly. So you'd gradually begin to cook the upper layers of the moon itself, not just the water. The surface would start to warm. Then it would start to glow. Then it would start to melt. As you continue to bombard the moon with microwaves, the upper crust would soften and eventually liquefy. Pockets of gas trapped inside the rock might violently expand and rupture, creating bursts of steam and plasma. Think of it as making lunar popcorn. Except instead of pop, you get geysers of vaporized rock ejecting into the vacuum. At this point, you might be asking, could we actually cook the moon all the way through? Let's do some very rough back-of-the-envelope calculations. The specific heat capacity of basaltic rock, the kind that makes up most of the moon's crust, is about 840 joules per kilogram macaque. The mass of the moon is 7.35 times 10 square Bannis kilograms. If we wanted to raise the entire moon's temperature by, say, 1,000 degrees Celsius, which is enough to melt rock, we'd need approximately 6.17 squares 10% of eighth joules of energy. That's a lot. For comparison, the sun emits 3.8 times 10 to 6 joules per second. So you'd need to beam the entire power output of the sun at the moon continuously for about 160 seconds, or 2.5 minutes to melt it. Of course, that assumes perfect efficiency and no heat loss, which is a tiny bit unrealistic. In practice, you'd be aiming your microwaves at one side of the moon, which would start to vaporize long before the other side even gets warm. The result? Thermal imbalance, structural collapse, and probably some violent moonquakes. The moon might start shedding material into orbit, forming a temporary ring system around Earth, made entirely of scorched moon chips. But let's switch gears. What if instead of building a giant microwave, you went the opposite route, shrinking the moon to fit inside your regular kitchen microwave? First, this requires a compression ratio of roughly 1 to 3 million, You'd need a technology capable of compressing matter without increasing its mass. Otherwise, you'd end up with a moon the size of a grapefruit, but still weighing as much as the moon, which would promptly fall through the floor, the planet, and probably tear a hole in space-time. Not ideal. But let's pretend for a moment you do shrink the moon, keep its mass manageable, and successfully place it inside your microwave. What then? Microwaves penetrate food to a depth of about 2.5 centimeters. The moon, even miniaturized, is not pizza. Its density and composition would cause uneven heating. Pockets of regolith would absorb microwaves poorly, while metal-rich regions might reflect them, creating destructive interference patterns. In other words, your mini-moon would explode. Not a nuclear explosion, more of a hot rock shrapnel inside a confined metal box kind of explosion. Also, let's not forget that lunar material is highly abrasive and may contain radioactive isotopes. You now have a radioactive, glass shard-filled mess in your kitchen. And your microwave? Completely destroyed.
Nope.
The warranty does not cover lunar destruction. At this point, you may be wondering, what about using the moon as a microwave? That's also not going to work. The moon has no internal power source, no moving parts. And it doesn't emit microwaves unless you count thermal radiation, which is weak and mostly in the infrared spectrum. Could we turn the moon into a solar-powered microwave satellite, beaming energy to Earth? That's actually a real proposal in space engineering circles. But it has nothing to do with cooking the moon. It's about putting solar panels on the moon and beaming energy home via microwaves. A very different, much less explodey kind of scenario. But none of this answers the fundamental question. Why would you microwave the moon? Maybe you're trying to bake the world's largest potato. Maybe you lost a bet. Or maybe you're just the kind of person who sees a 7.35 is 10 kilogram object in the sky and thinks, what if I nuked that thing with household kitchen tech? Whatever the reason, the consequences are, in short, not great. Melting the moon would destabilize its orbit. If enough mass is lost or redistributed, tidal effects on Earth could change. Ocean tides would shift. Earth's axial tilt might wobble. No more full moons, no more eclipses, and worst of all, no more werewolves. In the end, trying to microwave the moon is, scientifically speaking, a very bad idea. You'll spend more money than exists, destroy a perfectly good satellite, and possibly trigger planetary consequences for every living thing on Earth. But hey, at least you'll finally have an answer to that age-old question. What happens if I microwave something I really shouldn't? Answer: the moon melts, Earth panics, and your kitchen explodes. So maybe just reheat your burrito instead.